This is the lesson for Handout 1A. And so let's take a look at our first few problems. They are using exponent rules. And so taking a look at our first one, we have an exponent that's a fractional exponent. So fractional exponents work this way. The numerator represents the power. So this is like the power here, or our exponent, and so that's what we're raising it to. And the next number, the denominator, represents the number of roots. And so when we do this, we have four numbers. That's what the number of roots are. Now, four numbers that multiply to make 16, but then we're going to raise this to the first power is what we're going to end up doing. And we're going to do that with the next number as well. So we'll take this 8, and we're trying to find three numbers that multiply to make 8. Now, it's three numbers because that's what the denominator is. So you see how the denominator is 3, and so we're trying to find those three numbers that multiply to make 8, but then we're raising that to the second power. So we go ahead and do that work. Four numbers that make 16, well, that's just 2, and we're raising that to the first power. So that'll be just 2. And so here we have three numbers that multiply to make 8. Well, that's 2 again, but we've got to raise it to the second power. And so 2 to the first power was just 2. 2 to the second power is 4. We multiply those numbers, you get 8. That's our answer. Here we already have it in the radical form, so we just find out square root of 64, which is 8. Here we need three numbers that multiply to make 27. That would be 3. So one of the things you can look for is if it's an odd number underneath the radical sign, your answer is going to end up being odd. Just as if it's an even number, your answer would be even. So just something to look for. The answer is 11 there. Here we have some exponent rules to deal with. First of all, this is a power raised to a power. And so this means three groups of what's inside here. So the key is to bring everything to that power and multiply those exponents. So it's two groups, or three groups of 1, which is 2 to the third power. Three groups of -4, which makes x to the -12th power. Well, we're not done yet. Whenever you've got those negative exponents, take their reciprocal. So move those to the bottom of the fraction, and then multiply out those 2's. So that makes 8 on top, x to the 12th on the bottom. So the whole reason for switching the x's to the bottom is to make positive exponents. A little bit easier to understand the problem that way. Here everything's being multiplied, so let's use that commutative property. Move the 8 and the 9 next to each other, and count up the x's. You got 4 here and 5 here, so we're adding the x's up because everything's being multiplied. And that's what exponents represent, is repeated multiplication. So we multiply the x to the 4th, x to the 5th just makes x to the 9th power. So I multiplied the 8 and 9 because those didn't have powers. We didn't see a power on them. Just 1 is the power, so we can multiply those numbers. That's how we got 72. On the next problem, we have to reduce the fraction. So look for common factors. So take out the 2 that goes into each of these numbers first. And so that leaves me with an 8 and a 9. Leave some room for the x's, and just think about how many are left and where they're at. You see there's more x's on the bottom of the fraction, so that's where we're going to leave them. So take away 3 x's from the top, 3 from the bottom leaves us with 2 x's left on the bottom of the fraction. Here this 1y takes away 1y from the top, leaves me with 3 y's on top. So 8y to the third over 9x squared. Our next problem, very similar. You're using the commutative property again. So 5 and 6, bring those numbers together. Count up the x's. Here you got -3 and +4, so you're adding those numbers up. You're adding those exponents up, seeing how many's left. So it's just 1x, so it's x to the first power. Do the same thing with the y's. You got 2 y's here and 5 y's over here. So that makes y to the -3rd power. So what you're going to do from that point is just multiply out these numbers and then take the reciprocal of any negative exponents. So what we have left is 30x all over y to the 3rd power. Well, the next one is a fraction raised to the -2nd. Well, that's okay. It's just each number is to the -2nd power. So 3 is to the -2nd, 4 is to the -2nd. Notice how there's no fraction here, so treat those as being on top of the fraction. X to the 8th, y to the -4th. Well, whenever you have those negative exponents, get rid of them first. Don't try multiplying the numbers. You'll end up having negative numbers or some strange thing. What we do with these is we take their reciprocal, just like we had done before. So any negative exponents, always take their reciprocal first. And you won't make as many errors that way. So 16 is what's on top because I took the 4 to the negative second. It goes on top, so that makes 16. X to the 8th is on top as well. 3 to the negative second goes on the bottom, becomes 3 to the second, so that's 9. So you see, when you have the negative exponent, you just take the reciprocal and it becomes positive, and then you can go ahead and multiply out those numbers. Y to the negative 4th goes on the bottom, so that becomes y to the 4th. And that's our answer. Well, the next one's a problem where we have to solve an equation. So the common mistake is people want to subtract right here, but you can't do that. You got to multiply first. That's what the rule says. The order of operations says to multiply before you add or subtract. So that's what we're going to do here to get rid of those parentheses. So we're left with 2 minus 15x plus 10 equals 4x minus 12 plus 6. So you go ahead and do some work there. Negative 15x plus 12 is what we have right here. And on this side, we combine some like terms. I've got negative 6. So I go ahead and start moving some terms around. So I'm going to subtract that 12 from all sides. And over here, I'll subtract that 4x from all sides. So what I have now is negative 19x equals a negative 18. So when I do the division, divide by negative 19, I end up canceling out just the negative signs. I'm going to leave it as a fraction, 18/19. That's my answer. Well, looking at our last problem here, it talks about a wire that's 36 inches long. So let's draw a little picture here of our 36-inch long wire. And we're cutting it into 3 pieces. So here's the first piece, second piece, and the third piece over here. So this is like piece number 1, piece number 2, piece number 3. And it talks about, it gives some description of these different pieces and compares them. So let's do this. We don't know what the lengths are, but we do know that they add to make 36. So we know that, like for instance, this piece, I'll just call X, maybe this one Y, and this one maybe Z. So I know that all of these pieces, X, Y, and Z, if I was to add them all together, they equal 36. Well, this is a fine equation, but the problem with it is that we have different variables. You see, I can't really solve for any of these variables because I have different ones. I don't know what they are. So what we need to do is we need to figure out how to write it with just one unknown. So that's where these next 2 sentences come in. Let's take a look at this first one here. The second piece, so second piece is Y, is this symbol, this word right here tells us equals. So let's go ahead and write that down. The second piece, which is Y, so Y equals, and then half the length of the first piece, so half of X. So that is an expression. We can use that later on. All right, let's do another one. The third piece is means equals, so let's write down the third piece. The third piece is Z, so Z equals 3 times as long as the second piece, so 3 times Y. So there we have some equations. Now, let's do this. We want just one unknown, so let's try this. We know that we have Y and X here. We have Z and Y here. Let's try to get Y by itself on this one, and then we can go ahead and come up with an equation, because we already know that the first piece is Y. We know the first piece is X, but we can go ahead and write this and come up with a value for it. So let's get this X by itself, so we can substitute something in for X. So right here, see, we could go ahead and multiply by 2. So if the second piece is half the first piece, that means that the first piece, X, when I go ahead and solve for it, I multiply the second piece by 2 and I get 2y. So the first piece is double the second piece. Alright, so what we're going to do now is we're going to substitute. We're going to take this 2y and let's put that in place of that x right there. Let's take this 3y and let's put that in place of this z right here. And now we'll only have one unknown. So let's go ahead and rewrite our equation here. Let's rewrite instead of x, we're going to write 2y. Well, y, well, that's already just y. And then instead of z, though, we're going to write down 3y equals 36. So now what we need to do is just combine some like terms. So we got the 2y plus 1y plus 3y's. That makes 6y's all together equals 36. You divide by 6, and we got y is 6. That means the second piece is 6 inches long. So 6 inches for this is the second piece. All right, well, we know that one. Now let's find the other ones. Well, all you have to do is take that 6 and put it in for these y's in these two expressions that we have here. So x, which is our first piece, is 2 times by 6, which makes 12. So that means the first piece equals 12 inches. And the last part here, 3y, so we have z equals 3 times by y, which is 6, and so that makes 18. So that means the third piece is equal to 18 inches. Well, that would be our answer for all of those pieces which we needed to find. So those are some problems similar to what you'll see on the handout number 1A. On the back side, though, we've got some other problems that are similar to part number 2, so check out that.